Hello, my name is Peter Haumer from IBM, and today I'd like to talk to you about next generation development tools, particularly for the enterprise application development domain. I want to talk about how new methods and technologies can be utilized to provide a modern development experience. So the overall context of this publication is DevOps. So DevOps is not only an approach for you to continuously deliver and by chaining up life cycles out of learning, thinking, coding, delivering, running, and managing, but also like a kind of cultural change. The ability to react to change faster, for example, requires not only that you have the right tools, but also the right methods and development approaches. But on the other hand, the tools are quite important in giving you the edge in terms of having tools that allow you to quickly build a change that you implemented or allow you to quickly share changes that you made with your colleagues for review. So the impact of open source is quite significant in today's approach to DevOps, as there are many current approaches that get kind of standardized or evolve in the open source and then adopted for commercial software development. And the message we want to give you is that the mainframe really is just another point in the DevOps pipeline that can participate in this round trip of phases in the same way as any other distributed system can do. The particular focus today we want to put on the developer. So surely we will talk throughout this conference and in other presentations that you see from IBM on all of these phases and all of the capabilities that we have here, but I want to zoom in now into this coding and build steps. So a developer being able to quickly analyze what the problem is, what they need to fix, for example, if a defect was found, being able to make those changes in an environment that they're familiar with, as well as then being able to build that directly ad hoc for themselves and so-called user build before they hand over those changes to the larger team for review and integration into a build. And I mentioned the role of open source and open technologies, and that's a key part of the story I want to tell you. How many of these popular open source project technologies and approaches, such as GitHub, Microsoft VS Code, Red Hat, OpenShift, Kubernetes, can be part of the enterprise application development lifecycle. When you look at statistics from general surveys, that you can see an overwhelming kind of response to these types of technologies and solutions that organizations really have the goal to adopt those, utilize those, as well as want to implement them into the organization. And so the role of mainframe is what we want to talk about. So the general assumption is that mainframe is just another point in that pipeline, that ZOS has been transitioned to remove the differences that serve no purpose. So the idea is really that we can provide applications and technology to run on ZOS that can be utilized so that, as well as that there's an ability to access the mainframe and ZOS through third-party packages, external sources, internal sources, and so on. So open source works on ZOS, and the idea of putting a build pipeline up, for example, around ZOS, for ZOS, is a thing of reality these days. So here are some choices of technology that you can pick and choose from that we are kind of experimenting ourselves with, right, by providing new solutions around these. You can see IBM products on the slide. You can see lots of open source projects on here, as well as third-party offerings and solutions that can all be integrated with each other. And when you work with your solution architects, you can pick and choose from these and build up the pipeline that works for your organization. Again, now zooming into the code and build area, I want to talk about our vision for building up what we call a bring your own IDE strategy. So the ability to have flexibility when it comes to the developers' tools that they use, the IDE that they use, or the editors that they use, the tools that they integrate with, the SCM, as well as how they build and deploy and make changes available to their team. So enterprise-wide standardization is a key word here. as well as then the automation aspect. So when we look at technologies, we look at, do they fulfill certain criteria in terms of architecture, as well as standardization. We're looking for standards that can be applied in more than one context, as well as the ability to make them part of the pipeline. So the way I'm organizing the rest of the presentation and the demo is around these 7 layers. So imagine you're building up software in a kind of layered way. You have some basic capabilities, you build on top of that more advanced capabilities, and build another layer on top of that with even more advanced capabilities. That's the approach that we're taking here as well. But the idea is that perhaps each of those layers can be interchangeable, because there are some interfaces or abstractions implemented with these that allow us to swap these things out against each other. So in terms of increased capability and complexity, we start with the top layer here, which is mainly, first of all, providing an infrastructure of APIs such as REST APIs that can run on ZOS, that gives us capabilities or exposed capabilities to be utilized. So ZSMF is such an example that gives us a REST API that you can access from the outside and do operations against ZOS with it. And Zowe CLI is an open source technology that utilizes these APIs and builds capabilities for running so-called command line operations. So you fire up your Windows CMD window or your Mac command window, and you can type in, show me the list of all my USS files in my home directory, or bring me up the list of members for a data set. Download this member from the data set, upload a new file, start a job, check the status of the job, and so on, right? So you get the idea of having REST APIs that can be programmatically accessed, and then giving the developer the CLI experience of doing this by a command line, completely independent of any IDE or integration, so they can utilize them the way they want. But then you can build on top of that. So you have these APIs, you have CLI commands and implementations of larger macros, so to speak, of commands, such everything that's required to upload a new dataset member and replace it, and starting a job for a JCL member, and so on. And you can put those together and put graphical UIs on top of that. So Zowe Explorer is such an example, a graphic UI that helps you then to graphically navigate and access your dataset members if you don't want it to by a command line. But then these explorers probably need to be implemented for different IDEs and have UIs in them that are platform specific. But then when you made the choice for a particular UI, you can build out capabilities. But even here you can use open standards and capabilities to make them interchangeable and reusable. So a key technology in the editor space is what is called the language server protocol, that kind of separates the language capabilities of like parsing a COBOL program and computing the data needed for an outline view, or computing the data needed for code completion when you press Control Space, and putting that into a separate implementation that's independent of the editor. And then that implementation can be plugged into all kinds of editors. In our case, it's plugged into VS Code, but it's also plugged into Eclipse There and Shay, and it can be plugged into any other editor that supports this language server protocol. And then we built on top more capabilities, right? Making Zowe Explorer extensible, so not only using ZOSMF, but what if we could use FTP and RSE, the Remote Systems Explorer API from IDZ, as an alternative to interact with ZOS, and then build even larger capabilities on top of that, such as user build with DBB, as well as then taking all of these components together, because here we're talking about different tools and different technologies that all can be co-installed on a developer's laptop, but the developer would have to do that. What if we could make that all easier and put them all together into one or many containers and deploy them dynamically to the developers when they need them? They need to edit a COBOL program. Okay, let's give them a container where they have all the tools available and installed for COBOL editing. Or they need to debug a problem with PL1. Okay, let's give them a container with a debugger and the PL1 tools, so that they don't have to install a lot of these things themselves. They would just use them in the cloud. And here we talk about the hybrid cloud. It's a cloud that you run privately, perhaps in your organization, but you could also rent cloud capabilities through services. So the vision for the container-based solution is to enable developers to self-provision the environments that they need very quickly and giving them access in the cloud to the tools that they need without having all this installation overhead. And so the technologies and the applications capabilities that we're working on are all centered around Red Hat and OpenShift. And the idea is to provide kind of different solution components that can run directly on OpenShift or interface with capabilities that run on OpenShift. So you can still your VS Code, for example, that you like to have on your desktop together with a virtualized sandbox, a ZOS system for a developer that they run in the cloud for development and combine those with each other. So the technology stack that we're currently providing is 3 different choices on the code side from the editor IDE point of view, the Microsoft Visual Studio Code VS Code extension that we are providing, Eclipse Shea, so running this in the cloud, in the container, and then only, or not only, but in the browser, as well as the rich Eclipse client IDE around IDZ. And then on the server side, so on the cluster itself, we also provide this sandbox. So the sandbox allows you to create or use an ADCD that we are shipping or that you have created and deploy this as a virtualized ZOS instance that runs on x86 clusters right now and will enable you to run your own ZOS environment for development. So the overall architecture would look like this. You have your OpenShift cluster from Red Hat. In there you run your instances of the sandbox. You can run your full IDE environment with all the tools pre-configured and installed on here. So the user doesn't have to install anything. They basically create the workspace and everything you can see in these boxes is pre-configured, pre-installed for them. Or you can choose to use your own IDEs that run on your desktop, such as VS Code, such as Eclipse, and interface and connect to the sandbox and work with it. Okay, let's look at some demos and some of these capabilities in action. So remember I outlined those 7 different layers on which you build things on top. So let's start from the beginning of these layers. Let's start with a simple Zowe CLI that I've already installed in here. And the Zowe CLI is extensible, so you can provide plugins for additional capabilities, additional protocols to use. So out of the box it uses ESMF, but here we want to use it with our RSE API. So if you're an IDZ user and you use the Remote System Explorer there, with a small update to that Explorer, you can then also utilize the RSE plugin and run commands directly from here. So Zowe RSE list all members of a data set that I have in mind. In this case, the one that has my COBOL programs in it. And it would retrieve now all those members on the data set and show me the directory. I can now download members, could modify them, I could use any editor that I want, and then upload those again and save them back and start jobs and so on. So the list of commands is quite exhaustive. In addition to doing this now with these types of commands, I will show you later how you can utilize those also in scripts to do some simple automation with it. You can also use the graphical tools for it. So here we have the VS Code editor, and we have installed various VS Code extension. So particularly the IBM Z Open Editor that's freely available on the VS Code Marketplace. You can see that almost 13,000 people have installed it already and use it. And we provide additional plugins that come with it. So debug support for the editor as well as the user build. Then I'm also going to show you a little bit later. And so this gives me basic COBOL and PL1 and assembler editing capabilities. I can bring up a COBOL program in here. It will show me things like an outline view that allows me to directly navigate to a particular place here. I can use code completion. As you can see, I start typing and it proposes commands that I could enter in here and code complete, and it will do the same thing with variables. I can look at the usage of my variables or where they've been defined. So here, for example, I'm doing an if condition on this variable, find all references or peek all references. Peek will open up a little code lens, as I call it, and then I can move directly in here, navigate to the different occurrences of that variable inside my program. So you see you got powerful tools directly available in here, tools that you're used to when you work with Java or JavaScript or other modern languages, also now available here for these types of languages such as COBOL, as well as PL1. Let me open a PL1 program here now. The same kind of capabilities. It will show me an outline view. It will show me now include files as well. So that's something I can also do in COBOL. Here I have an include file. I can do a control click on it to open that file. I'll go to definition. Oh, that's happening. And open the file directly from here, and so on. And then assembler is a language that we just added recently, so have very similar capabilities of hovers and code completion and so on for the assembler language as well. So in addition to being able to edit files in here, you can now interact with the OS using the Zowe Explorer. That's fully integrated now in this experience. It gets automatically co-installed when you install the Open Editor, and now that gives you access to your data sets, your USS file, your jobs. You can run simple queries similar to what I just typed earlier with a command line. I can now use dialogues for that and bring up again the list, in this case of my data sets, and open COBOL files directly from here, make edits directly in MVS and save them back, and so on. And so here I'm using an LPAR that I'm using for demos, but I will show you also in a moment how you would utilize a sandbox. So if a sandbox was configured for me, I can create also a connection to the sandbox and add that in here as well. So now I'm on a Windows desktop, but I'm using now the sandbox that runs on OpenShift and have the same seamless experience in here of retrieving my data sets, open COBOL programs from here as well, and having really almost the same kind of responsiveness as I would have with the LPAR. Of course, it's a little bit slower, it's emulated, but I can run user builds in here, can do all things that I can normally, almost all the things I can do on the hardware. Now that we've seen editing capabilities on the desktop with VS Code and the Open Editor, let's move to the cloud and see how you get a very similar experience, but with additional flexibilities. So here we have Red Hat OpenShift, and the idea of deploying applications in OpenShift is by using so-called operators. So the operators are provided and used by the cluster administrator, and we provide additional operators to the standard catalog that comes with OpenShift. In this case, if we search for Wazi, we find our two operators in here to deploy the Wazi development client as well as the IBM Wazi Sandbox. And so these can be deployed and configured independently. You can set up a bunch of sandboxes. You can deploy the development client for multiple teams. Teams can share deployment and still have full privacy, and nobody can access their files, but you can also open up workspaces that one developer shares their workspace with another developer for co-development. And so there's a lot of flexibility in how this can be configured and being deployed. So let's have a look at the sandbox. Once that's been deployed, you can create instances of those, and then a developer can log in here. You can see now I switch to another tab with the developer UI for OpenShift, and then they find entries in here that they can click on that give them then the information that they need to access and utilize their sandbox. So here they have a sandbox configured for them. They can see now the technologies that are available that can be accessed remotely on this US system. The SSH port typically is 22, but when it gets deployed into the cloud, it gets mapped against another unique available port in the cluster. So the developer would now use this port 32168 to open up an SSH shell and access it. And you earlier saw me using the RSE API. The API server is fully deployed in the sandbox, and I can directly access it. And here's the port that I'm supposed to be using. So the developer has an overview here now to access these services. Then they will also have access to the Wazi development client. So the idea is, again, here, this gets installed and deployed by the administrators, and then users get a URL with a username and password that they log onto, that they can then access this installation. So in this case, I already have logged on to this. Let's get to the top Getting Started page. So this will be the first page that they would see. And then they can see different stacks in here of pre-configured configuration of tools and editors and middleware that they can instantiate and create their own personal workspaces for. So right now you can see there's only one Wazi development client tile in here with all our tools in there, but this is entirely customizable. So your administrator can configure all kinds of other combinations of tools that you need in your organization, in your environments, and provide many more tiles in here for your specific type of development. As you can see, there are other technologies available here already, C++, Java development, so it uses standard technologies for those. The specific enterprise languages would be in here. So all the user has to do is select a tile, click the Create an Open tile, or they can even customize this further by selecting specific components they want to have switched on and off, as well as perhaps a Git repository that they want to get cloned automatically and have the code available when they get into their workspace. Then the workspace gets started, and it appears here in this list. So I already have my workspace running as I set up before this demo. And I just click on it, and it will basically load the workspace. And the user experience that you can now see here is very similar. Just opening up some README files that the administrator have configured. And now I'm back in my COBOL editor. I'm using here deliberately the same sample as before. You can see that the experience is almost exactly the same. Just the outline view right now is here on the right-hand side. But if it comes to like keyboard shortcuts and the menus up here, this has been designed to be entirely similar to VS Code. So if you worked in VS Code before, but you quickly need to try something out in the cloud, you will have no problems using these tools in here. You have the same types of integrations and additions in here. So for example, Git tools you have as well. So I wrote some scripts for this demo and made some customizations of our default script for this particular demo. And I can bring up like a side-by-side view to see now if I would commit this, what the changes would be for my Git commit, and I can revert changes and so on. So similar tools that you used to from VS Code, you will find also in here in this experience that runs entirely in the browser now. I can also open up a terminal now and run Zowe commands. And so the same ability of running a, let's just bring up the help now, RSE -help, show me all the RSE command, but this the same ability you have here as well. And I mentioned that you can use these Zowe CLI commands to do some automation. So here's such an example of a little script that I wrote that can do things like allocating data sets for me. I have a JCL for that, and it would just perform those allocations and then upload COBOL programs perhaps into these new data sets and then submit a run job. So the JCL, I've edited all here locally. Here's my run JCL, and the script will basically upload that JCL and execute it. Then I can wait for the results and download the results and see the results directly here in action. So to execute this script, let me go into the right directory and then run the scripts, and you would see basically it performs these different steps, and I put in like echo statements to log my completion in here. So you can see with the CLI capabilities, you can automate and create these kind of macros that do things for you, particularly for perhaps your specific setup and your environment that you need to be doing. So now you can see I'm submitting my JCL job, and it gives me the job ID. Now I could go back and look at the job ID here using my Zowe tools. So I could just bring up all my jobs under my name, or just look for a particular job ID. So the 9612, as you can see, was executed in here, and I can bring up the output from this, and I have immediate access to all of those resources through the OS. In addition to writing your own scripts, we are giving you another capability which is called IBM User Build. That utilizes the IBM Dependency-Based technology. So I've set up Dependency-Based build on my ZOS system, and then I can configure basically the connection to the system, as well as how the parameters and so on that I've configured once, and then I can basically do right-click operations. I've made some changes to this particular SAM1 COBOL program. I can right-click on it and say run my user build using my settings. You can see my settings also get output in here. And then it basically uploads my program that I just edited here because I just made changes. It also recognized that I've included copybooks in here that are also locally present that might have been updated. It will upload those as well. And then it will start off a groovy DBB build script to now build my application and then execute it, and then download the results for me. So you could see different types of automation possible directly out of these IDEs, and giving you all kinds of flexibility. Okay, that concludes my presentation. We would be very much interested in any feedback. So a lot of the things I've shown you today are freely available, or we have trials of them. Go and visit us either on the IBM product page or Wazi for Red Hat CodeReady Workspaces, or our Z Open Editor about. From there you would find a lot of other pointers and presentations and the downloads for the trials. And we have surveys, but also provide the ability to file GitHub issues to give us feedback. Thank you very much for your attention.